Hello and welcome to this video. We are going to be reviewing how to write the formula for compounds given our cation and our anion. And before we get started, if you do not have with you your periodic table and or your polyatomic chart, you need those out and ready to go. So pause the video if you don't have those and get those out. If you have them out, one of the things that I am seeing that a lot of students don't seem to be remembering is your oxidation numbers. So that's the first thing. Now, if you lost the sheet that when we were working with the periodic table and oxidation numbers and naming the periodic tables, groups and families and so forth, and you did not write down somewhere or have the oxidation numbers, I would make a very strong suggestion that you go back in, maybe even on this laminated one, and put them on there. I saw somebody in class, I can't remember who it was, who had sticky notes that they had put them on there, and that would be not a bad thing because you could take those off if you're not allowed to have them. But I'm going to go ahead on mine and just write on it. So hopefully you remembered that if you are in group 1, okay, group 1, that you have a positive 1 as your oxidation number. If you are in group 2, it's a positive 2. Now, we skipped the transitions because some of those could have multiples. And I'm going to go ahead and grab a sticky note here and just put on a note here that says that if you are using any of the transitions, okay, so I'm going to put it there, that they have multiple charges, and then therefore we use Roman numerals when naming. Okay, so that would not be something that it would hurt to put on your paper. Okay, so that is our yellow area here. Okay, so if you're looking at this periodic table, it is that yellow area. When you get over to the boron family, group 13, those are +3. Now, some of those might have multiples just because some of them do act more like the transitions, such as when you get down in here to lead and tin and so forth. But for the most part, +3. The carbon family can either be a plus or a -4. You see that a lot. And then the nitrogen family is your -3, oxygen family -2, and fluorine family a -1. Okay, so again, if you don't have those on there, I definitely would suggest that you mark them somewhere, or definitely have that sheet out that we completed first semester that had all those values on there. The other thing that we look at that I'm seeing a lot of people are having trouble with is that if your anion, okay, if your anion is any of these on the periodic table, anion being your negative, okay, then the name will end in "ide." The name will end in "ide." Okay, so I see people forgetting that. So let's go over to the back side real quick. So on the back side of your periodic table is your polyatomic ions. Guys, these are already the names of your polyatomic ions. You will never change the name of a polyatomic. Okay, so I'm going to get me another sticky note and put up here. Okay, so you will never change name of polyatomics. I wrote that kind of low. Okay, so if you see the word nitrate, given to you, then in the name, nitrate will be there. If it is nitrite, nitrite will be in the name. Hydroxide, hydroxide. You will never change these endings. Okay? So don't forget those things. So we're going to go through this sheet. I'm going to try to take it very slow so that you can follow along, hopefully, on what is taking place here. So the very first thing that I'm going to do is I'm going to go ahead and instead of writing on the formula line that so many of you are doing, I'm going to write above the elements that are given. So this is magnesium. And again, if you don't know your symbols, you need to learn those. This is magnesium and this is fluorine. So the first thing I do is I know, okay, they're both on the periodic table. So I'm going to go to my periodic table, and the first thing I'm going to do is find magnesium. It's right here. And so magnesium is a +2. So I'm going to put out on top of here a +2. Now, I have to have always a plus and a minus, a cation and an anion. And so with that being said that magnesium was a positive, fluorine has to be the negative. And here it is. It is a -1. Now, when you look at these two, remember the charges on your compound must equal 0. And so if I am looking at, let me grab a piece of paper here handy. I'll write on this here. But if I have a +2 -1, that does not equal 0. Not going to happen. And so when I look at this problem, I have more positives than I do negatives. So I need another fluorine. Now when I look at it, I have 2 positives and I have 2 negatives, and that makes it 0. Therefore, when I come over here to my formula, I have 1 magnesium. Now I'm going to put that 1 there for right now, but we'll talk about it. And I have 2 fluorines. Okay? Now, the key is, though, when we're writing compounds, we do not put the ones there. They're understood. Okay? So I put it there just so you could see that, but that is not, it's just understood, so we're not going to put it on there. Okay? Now, let's talk about the name of it. Again, I told you, if your anion, and remember your anion is your negative ion. If your negative ion is from this periodic table, you're going to change the ending to "ide." So for this problem, I leave the first word exactly the same. It will never change. Magnesium. And then I take my fluorine and I change it to, instead of fluorine, fluoride. Okay, fluoride. So you have MgF2 magnesium fluoride. Okay, let's do the next one. So sodium. A few of you guys are still using sodium as an S. Sodium is not an S, it's Na. And then I'm going to go to my periodic table. And here's sodium. And it is a +1. Okay, so the next thing we need is hydroxide. And one of the ways that you can tell is, one, hydroxide, hydrogen, oxygen. You can already tell it's 2 put together, so you should recognize that. And as much as we've done it, also you should recognize it. So look on the back of your periodic table, and let's find hydroxide. Again, here it is, hydroxide. It might take you longer than me to find it, but here it is. It is OH, and it has a -1 charge. So I'm going to write that down. OH, and it has a -1 charge. Again, when I look at my charges, I have a +1 and a -1, +1 and a -1. So that is going to become 0. Therefore, I just need one of each. So I come over here and write NaOH. Now, guys, some of you are putting parentheses around the OH. If you only need one, do not put parentheses. Okay? Naming. The first element is always the same, or polyatomic, whichever that may be. In this case, it's an element. So we're going to write sodium. And then this one comes from, again, what I told you earlier. You never change the name of a polyatomic. You just write that word out. So this is hydroxide. And you're done. Number 3, potassium. Again, some of you have not learned that potassium is a K. Iodine is also an element. It's an I. Again, I'm going to go to my periodic table, and I'm going to find potassium right here. It is a +1. I'm going to find iodine over here, and it is a -1. So +1, -1. Again, just like above, they're going to zero out. So I only need one of each. So it's Ki. The first element or polyatomic stays exactly the same. So potassium. And now again, we are on the comment here that says, if your anion is from this periodic table, from the front side, all you do is change the name ending to "ide." So instead of iodine, it's iodide. Okay, I'm going to do one more. So the next one is lead 2 nitrate. So lead is Pb. This is where we're given the Roman numeral, because again, our note says that the transitions have multiple charges. They give us Roman numerals, but guys, we only put those Roman numerals when we're naming, not when we're writing the compound. So when I go to look at this, lead, they tell me it is a 2+. Chlorine, Cl, if you don't know where it's at, it's right here, 1-. Okay, again, when I look at this, I have 2 positives, 1 negative. That means I'm going to need more negatives. In this case, I need 1 more, right? So 2 positives, now I have 2 negatives. Okay, so 2 positives, 2 negatives, it does equal 0. So I'm going to have only 1 lead. I have 2 chlorines. And there's my formula. Now to write the name again. All I've done is use this periodic table. Chlorine was over here as my anion. So again, all anions name ends in "ide." So I'm going to change the chlorine to chloride. Now, when you go to name it, you do have to put the Roman numeral in the name, as I stated on that sheet. Again, chloride. Okay. Do not, I cannot emphasize this enough, do not put Roman numerals in the formula. They will only ever be in the name. So again, look through those problems. Think about where you're having issues, and you can let me know if you need more help.